These are the 6-7 notes, and in 6-6 we started talking about what a matrix was. We talked about the different pieces of it and how the numbers on the inside are called elements, and we can add them and subtract them and multiply them by something called a scalar. Now I'm going to talk about why it's important in Chapter 6. Because Chapter 6 has been about systems of equations. So why would I need to know about matrices? Well, we can use something called an augmented matrix to solve systems of equations that might be too difficult to use elimination or substitution. So an augmented matrix is a matrix consisting of the coefficients and the constants terms from a system. So we talked about this a little bit where a system of equations is great, but what do I do with those equal signs? We're going to have a dashed line that represents the equal sign. First, let's go ahead and put in our coefficients. Remember, the coefficient is the term in front of the variable, or the number in front of the variable, sorry. We'll start with the first one. I have x, which is the same thing as 1x, so my coefficient is 1. Then I have minus 3y, so it's actually negative 3 and 8. Negative 9, 2, and negative 4. But something happens in between these terms and these terms. We have an equal sign, so we put a dashed line in there. Okay, something that you need to make sure of is when you put them in an augmented matrix is that you have the x's in one column and the y's in the other. If you have to rewrite one of your equations to make sure that they line up, do that first and then make your augmented matrix. Okay, so let's go down here and try another one. We have negative 2x plus 7y equals 11, 6x plus or minus 4y equals 2. So we're going to go ahead and make our matrix. We have negative 2, 7, 11, 6, negative 4, 2, and then we have the dashed line right there. Okay, turn to the next page. There's 3 more examples. I'm going to do B with you first, and then I'll let you do the other ones. Okay, up here I have x minus 2y equals 5, and then y equals negative 4. Biggest thing is, this one doesn't have an x, so I'm going to rewrite it as 0x plus y equals negative 4. So then when I fill in my matrix, I have 1, negative 2, 5, 0, 1, negative 4, and a dotted line right here. Okay, I want you to go ahead and do the next 2 on your own. Pause the video, come back when you're ready. I'm going to keep going. So over here we have our first line. We have 6, negative 8, negative 10. Now the negative 5x should be lined up with the x's, so I'm going to put negative 5 here. I have 0y, so 0, and then negative 20. Down here, these two are not in the right order, so I'm going to rewrite it as 2x plus 3y equals 12, and then I'm going to fill it in. 3, negative 2, 6, 2, 3, 12. All right? Turn to the next page. So all of those things are really great. We can put them in the matrices, but we need to know, what does it have to do with solving a system of equations? Before we get started, remember that when you're solving a system, you should get an answer for each of the variables. Today we're just going to be doing 2 variables, x and y, so you should get an answer for x and you should get an answer for y. We're going to do something called a row operation in order to start solving these things. There are several different row operations that you can do. The first one is you can interchange any 2 rows or swap them. So up here I have 2, 1, 3, and 4, 6, 7, but I want the 4 up top. And you'll see later on in our examples why you might want that to happen. So I can just swap them out. So it becomes 4, 6, 7, 2, 1, 3. That's just fine. That's called swapping row 1 and row 2 because this is row 1 and this is row 2. Okay? Or I can multiply all the elements in a row by a non-zero constant. I cannot multiply by 0, but anything else is fine. So up here, let's pretend that this was our system and I had 2x plus 1y equals 3, 4x plus 6y equals 7. I would want to make some of these line up, right? If we wanted to get rid of one, I would want maybe the 4 and the 2 to match. I can multiply just row 1 by 2, a constant, to make it match up. So I get 2 times 2 gives me 4, 1 times 2 gives me 2, and 3 times 2 gives me 6. And then I left the bottom row the same. I should have made a dotted line here, so go ahead and do that. So you can do that. You can also multiply both rows by different numbers. That's fine. The biggest thing is if you multiply a row by a constant, you have to multiply the whole row. So I can't just multiply the 2 and the 1. I have to include the 3. Another operation is to replace one row with the sum of that row and a multiple of another row. That seems like a lot. I'm going to show you what I mean. So if I'm up here, I have 1, -1, 4, -5, 3, and 6. I want to make the 5 and the 1 match up so that I can get rid of something. So I'm going to multiply row 1 by positive 5 so that they match up. So now I get 5, -5, and 20. And these match up that I can get rid of them. If I add them, I can keep the original row. So I brought this original row back down here, which is just fine. And then I said when I add these, I'm going to replace the second row with the sum that I get. So I did 5 plus -5 gives me 0. -5 plus 3 gives me -2. 20 plus 6 gives me 26. That's kind of complicated, but if you think about it, it's very similar to using elimination with multiplication. Now, sometimes not replacing this with what I had before is confusing. So if you want an in-between matrix where it's 5, -5, 20, and then the sum 0, -2, 26, that's okay, but we're trying to simplify these as much as we can. So we're going to multiply the first row by 1/5 and reduce it, and then we'll get our 1, -1, 4, 0, -2, 26. Okay? If you can see how we went straight from here to here, where I kept the first row the same as it was in the original problem, and then I replaced the second row with the sum of these two rows, that's just fine. Okay? Turn the page. Row reduction is the process of performing elementary row operations on an augmented matrix to solve a system. So we want to say the process of using row operations to solve a system. We're going to simplify that. Okay? So I just showed you the different row operations that we're going to use in this lesson, where we can swap two rows, multiply a row by a constant number that's not 0, and then I can also use row reduction by adding and replacing them with their sum. So, but that still doesn't help me. How am I going to solve them? I can simplify those things all I want, but what does it mean? A matrix is solved, or in the identity matrix, when it gets down to this. I have 1, 0 and a number. Remember that dotted line. 0, 1 and a number. This is just like a fun fact. This matrix is called the identity matrix. We're going to get to what that means a little bit later. But why does it work if I have a matrix that looks like this? If we come down here, let's take a look at the first row. The first row says 1x plus 0y is a number, right? If we rate it with coefficients, 1x plus 0y equals a number. That's the same thing as x equals a number, because 1 times x is just x, 0 times y is 0, and then the number stays the same. So it tells me this is what x equals. Now if I look at the second row, I get 0x plus 1y equals a number, or y equals a number. That gives me what y equals. And that gives me my ordered pair, x, y, which is my solution to a system of equations. We're going to practice getting it down to this identity. So go ahead and turn the page. Alright, I have a system of equations. I know I could use elimination here, but we're going to practice it with a matrix anyway. So I'm going to set up my matrix. I'm going to say -5x plus 3y and then 6. Let's put our dotted line in there. And then I have we should get rid of those. Let's start that matrix over. We shouldn't have included the variables. -5, 3, and 6. 1, -1, and 4. And then include your dotted line. Keep in mind, I'm trying to get to 1, 0, and a number, 0, 1, and a number. Okay? So let's start some of our operations. Let's say I want to get rid of that 5. So I'm actually going to swap these first because do you notice how the 1 is already in that position and I want it to be here? So let's swap rows 1 and 2. Okay, so if I swap them, I get 1, -1, 4, -5, 3, 6. All I did was put this one on top and this one on the bottom. All right, I'm trying to get rid of that 5, so I'm going to multiply the top row by 5. I'm going to come over here and work just in case we run out of room. I'm going to say multiply row 1 by 5. And I get 5, -5, 20. And then the bottom row stays the same. -5, 3, 6. Okay? Now I'm going to make this 0, so I'm going to say add row 1 and row 2. So I'm going to keep the top row the same, which is, let's bring this one down here. 1, -1, 4. And if I add these, that's what's going to happen, or go in the second row. 5 plus -5 gives me 0. -5 plus 3 gives me -2. 20 plus 6 gives me 26. Which, this is really good news because if you take a look, I already have 1 in this position and 0 in this position, which is great because that means I only have to deal with these two numbers now. First thing I want to do, simplify this second row. There, 2 and 26, which is can be reduced by 1/2. I am going to reduce by -1/2 and make this a +1, which is what we want up here. So multiply row 2 by -1/2. So my top row stays the same, and I get 0 times -1/2 is just 0. -2 times -1/2 is -2 over -2, which is just +1. And this 26 times -1/2 is -13. Okay? I have a 1 here, a 0 here, and a 1 here. The only number I have left to deal with is this one right here. So all I have to do to get rid of that is let's just add these together, because if I add the 0 and the 1, I'm going to get 1. If I add 1 and -1, I'm going to get 0 right here where I want it. So I'm going to add row 1 and row 2, and my new row will go in the first row. So the answer that I get when I add them will go in the first row. 0 plus 1 gives me 1. 1 plus -1 gives me 0. -13 plus 4 gives me -9. And I am going to leave that second row the same, 0, 1, -13. Now, do I look like the identity that I was talking about? 1, 0, 0, 1, and 2 numbers? I sure do. So that means that x equals -9 and y equals -13. Okay? That's a lot to take in because you have to decide, where do I go from here? This is where your critical thinking is going to have to come in. You're going to have to decide, what's the best move for me? Should I multiply? Should I multiply by a fraction? Should I reduce? Should I add 2 rows? And if I add 2 rows, which one do I replace? Keep in mind, this is your end goal. So change one number at a time and try to make it get to look like this. So let's turn to the next page. I'll do one more with you. So let's set up our matrix. We have 1, 2, 6, 2, 1, 9. Okay. First things first, my 1's already here where I want it to be. I'm trying to make it look like this. Okay, this 1's already where I want it to be. So let's try to make this a 0 first. So what I'm going to do is, in order to make this a 0, I have to make this be a number that I can get rid of it, which would be negative 2 if I add. So negative 2 plus 2 will give me the 0 I want. So I'm going to multiply row 1 by negative 2. So I get negative 2, negative 4, negative 12, 2, 1, and 9. Okay? And then, after that, I want to add row 1 and row 2, and I'll replace the second row. Now, because the first row already started to look like what I want, I'm going to leave it the same, 1, 2, 6, and I'm adding these to get my second row. Negative 2 plus 2 gives me 0. Negative 4 plus 1 gives me negative 3. Negative 12 plus 9 gives me negative 3. Okay? Now, I have a 1 and a 0. The next thing I want to get is either a 0 or a 1 here. Let's start. It's a little easier to get a 1 here and then go from there to make this what we want. So, I'm going to multiply row 2 by, now we want it to be a positive 1, so we're going to have to multiply by a negative and 1/3. So I get 1, 2, 6, 0, 1, 1. Okay? I have 1 here, 0 here, 1 here. The last thing I need is a 0 here. So let's use some multiplication to this row to make this one a 0. So I want to be able to add this number to make 0. The way I'm going to get there is by multiplying this by a negative 2. So multiply row 2 by negative 2. So I get 1, 2, 6, 0, negative 2, negative 2. Now I'm going to add these two rows and replace the first one with my answer. So if I have, let's see, add row 1 and row 2, 0 plus 1 gives me 1. Negative 2 plus 2 gives me 0. Negative 2 plus 6 gives me positive 4. Now I want this one to stay the same because it was already the way I wanted it to look, so I'm going to go 0, 1, 1. Okay? So I have the identity here that I wanted, and I have two numbers over here that I want. So my answer is x equals 4 and y equals 1. Okay. Turn to the next page. I want you to try this one on your own. Pause the video, come back to it when you're ready. I want you to try this one out until you get two numbers, okay? You will not get fractions or decimals. So if you get fractions or decimals, try again until you get whole numbers. So let's set up our matrix. We have 2, negative 3, 3, 1, 1, 14. Now, it's easiest if we start off with the 1 in the top position. So let's swap rows 1 and row 2. So I have 1, 1, 14, 2, negative 3, 3. Now that 1 is where I want it to be. The next thing I want to do, I want to get a 0 here. So I'm going to multiply that top row by negative 2. And I get negative 2, negative 2, negative 28, 2, negative 3, 3. Now I'm trying to make this one 0, so I'm going to add them together and replace the second row with what my answer is. So I'm going to add row 1 and row 2, but I'm trying to keep that top one the same, so it stays 1, 1, 14. The answer to that addition will go in the second row. Negative 2 plus 2 gives me 0. Negative 2 plus negative 3 is negative 5. Negative 28 plus 3 is negative 25. Okay, so let's start now by making this the one we want it to be. So I'm going to multiply row 2 by negative 1/5, 1, 1, and 14, 0, 1, and 5. Okay, now I want to get rid of this and make it a 0. So to do that, I have to add these, but if I add them right now, I will get positive 2. So let's multiply row 2 by negative 1 to make this a negative 1 that will give me the 0 that I want. So multiply row 2 by negative 1. 1, 1, and 14. 0, negative 1, negative 5. I'm trying to make this 0, so I'm going to add rows 1 and row 2, replacing row 1. So 1 plus 0 is 1, 1 plus negative 1 is 0, 14 plus negative 5 is 9. Then I'm going to keep this one the same because it's already done. And I have my answers. X equals 9, Y equals 5. Turn to the next page.